Hey guys, for lab today, what you'll find in the Schoology folder is you will find a lab that says hurricane motion, as well as a video, this video that you guys are watching. I'm going to take you through the gizmo so that you guys can kind of work on the lab independently while watching my video. Okay, so we're going to skip right to this gizmo warm-up thing right here. And you can use data collective. So this is a cool little gizmo showing you the hurricane swirling around. And we're going to do a couple of things looking at radar and satellite and the movement of the hurricane and see a little bit about a hurricane. Okay, so there is such a thing called a weather station, which looks like this right here in your picture. And basically, it's a dot with a stick coming off that tells you the wind speed. The dot is telling you how much the cloud is covered. And you see here on your screen, it tells you what percentage. If it's a white dot, it's clear. If it's a totally blacked out dot, it's completely cloudy. And this is telling you what percentage of the air and a fraction is covered by clouds. That's the dot. The stick here with the little weird things coming off, that's telling you wind speed. Okay, and then another thing that's not on there is air pressure. So if I put the weather station data on the map here, you see how I have the circles with the different shaded portions in. I have the sticks coming off, and then these numbers are the air pressures. Okay, I'll tell you what the air pressures mean another time. So it's telling you a little bit about it here. So use the information to complete this table for station A here in your paper. So let's take a look at station A. So the way that the this works is that the big triangle is 50 knots, okay, and then the long stick is 10 and the short one is half. So I'm going to add this in maybe right about here, and it says that right here, okay? The flag indicates the knots. 1 knot is equal. So the short line is 5, the longer line is 10, and the big one is 50. They say that, so I'm going to bold that and make it stand out to you right there so you can see it. You add all them together. So A is 50 plus 10, 60 plus 5, 65, okay? Whichever direction this is pointing to is the direction that the wind is from. So this is pointing to the east, right? So this is wind from the east. The cloud cover is completely full, so you can say the words overcast. And the pressure, there's none there, so you can just leave it alone, none. Okay, they don't give you any numbers here. So let's move on and take a look at this. So we want to make sure this is practice. We want to show the hurricane, which we got, and show the weather station data, which we got. So it says hurricanes form low pressure over warm waters, and they rotate counterclockwise, and the Coriolis effect causes that counterclockwise rotation. So it says here, in which hemisphere is the hurricane shown? This is the northern. And how do you know? The counterclockwise rotation only happens in the northern hemisphere, okay? Next, under the hurricane, make sure radar is selected. Let's change that to radar. So blue is light rainfall. The colors correspond to the severeness of it. Yellow is heavy rainfall. Orange is even heavier. And red is the heaviest rainfall with that white color in the center, which is the eye of the storm. So where within the hurricane is the lightest rainfall? That is the eye. Where within the, oh, sorry, not the eye. I read that wrong. The lightest rainfall is the outside of the hurricane. Where is it the heaviest? The eye, which is the center. Describe any patterns you see in the distribution of the hurricane's rain. Well, the heaviest, actually, I want to make this red. Heaviest in the center and lighter as you move away. All right, so now let's actually get to some stuff. Under show the hurricane, now let's switch back to satellite. Satellites are taken from cameras and satellites around Earth. Which is larger, the area of rainfall, the area of cloud cover? So let's take a look. Rain, Cloud. Rain. Cloud. What's larger? The cloud cover. It doesn't always rain when there's clouds. Where is the clouds the most dense? This is, again, the most dense is closer to the center. Where is it the least dense? Where are there less clouds? So this is measuring clouds, guys, not just rain on the outside edges. All right. Moving on. I'm going through this quick, guys, but I have a video. You can do this. Stop it and pause it as much as you like. So the center of the hurricane is called the eye. It is actually right in the center. It's actually pretty calm with low pressure, light winds. Maybe even the sun is shining through. So this is the eye. You don't have to label anything. That's the eye. Okay? All right. Next, wind speed. So we've talked about this before with another lab, but wind speed is categorized, hurricanes, are categorized based on their wind speed. Once it reaches a certain wind speed, it's categorized as a 1, a 2, a 3, a 4, or a 5 category hurricane. Okay, so move the hurricane so that the center of the storm is almost directly over a weather station. So I'm going to move this, okay? I'm going to move it right over area C, right here. Okay, it's pretty close to it, okay? Not quite on top. So what is the wind speed? We'll take a look where I just did it. That's 2 flags. Remember, each flag was 50. So what's the wind speed in knots? 100. One knot is actually equal to 1.15 miles per hour. So what would that be equal to? Well, it'd be equal to about 115 miles per hour. There is going to be a point in time which you guys are doing this on your own. So what is the category then if it's 115? I would like you guys to answer this one yourselves. Take a look at 115. Where would it fall? Please write down what category that would be. You're doing this one on your own. All right. Now, we're going to move the hurricane toward a different weather station. Let's go over here to A. Get pretty close to A. So as we do this, notice what happens to the cloud. So let's move it away again. Let's take a look at the clouds. No clouds. The wind is 10, 20, 35, and the air pressure is 1024.3. Okay, that's the pressure. Cool. Watch what happens to all 3 of those things as I move it. And that's what you guys are going to answer here. So you're going to answer 6A, B, C all on your own right now as I do this. So pay attention to what happens to cloud, wind, and air pressure. You know, it's hard to read it, but the air pressure says 9,054.5. So I'm going to move it away again. So as I move the hurricane closer, what happens to the cloud coverage? Does it increase or decrease? What happens to the air pressure? Increase or decrease? What happens to the wind speed? Increase or decrease? So please answer these ones right now on your own. Let's move on to number 7. We're going to move the hurricane north, east, south, and west of a weather station. In the table below, record the wind direction in each case. Okay, so I'm going to kind of move it back here towards C. So I'm going to move this hurricane east towards C. Tell me what happens to the wind direction. Remember, whatever direction that this stick is pointing to is the wind direction. So as I move it towards it from the east, actually, let me rephrase this. Let me start with the north. Sorry. So as I want to go down, so I'm north of the hurricane. The hurricane's north of the weather station. Which direction is this pointing? That's what you're filling in right here. I'm now going to come at it from the east. Which direction is the thing pointing? That's what you're going to do right here. I'm going to come at it from the south. Which direction is this pointing? That's what you're going to put right here. I'm going to come at it from the west. Which direction is this pointing? And that's what you're going to put right here. You can always stop and rewind my video if you need to see that again. 8. How can you tell the location of a hurricane relative to the weather station based on this information? So based on right here, take a look at it. Think about it. How can you tell where the hurricane is based on the wind? You're going to answer that right there. Looking at what we just did up here. as well as this stuff above at number 6. All right, let's move on. So now we're going to go back. We're going to click on Experiment, and we're going to pause. Okay. So eventually I'm going to click play. You're going to wait until the hurricane is approaching one of the weather stations. Then we're going to pause it. What changes indicate the hurricane is approaching? So I'm going to hit play. When you see a hurricane approaching one of the weather stations, I don't know where the hurricane is, what changes are you noticing in cloud cover, wind speed, and air pressure that shows the hurricane is approaching? So there's the hurricane down here. So it's on effect weather station A. What changes in cloud coverage, wind speed, and air pressure are you noticing as the hurricane gets closer? So you see how close it is now to A. What is happening to the cloud coverage, the air pressure number, and the wind speed? So look at those little things there. And now it's moving away, so let's pause it. Now, what happens until it goes over land next? Click play and wait for it to go over land. What happens in the hours after it makes landfall? So what happens to the hurricane once it hits land? Describe the shape of it, the size of it. What happened to the hurricane once it hits land? Describe what happened to it. Good. All right. Now we're going to reset, and we're going to turn off Show Hurricane. We're going to click play, and it's going to reset it back to, so down here at the bottom it says day 1, and it gives you different times. When it hits 3 p.m., I'm going to pause it, and you're going to write down what each of these things are at A, B, and C. I will do the first one for you so you can see what's going on, then you guys can do B and C. So let's hit play. We're waiting for it to hit 3 p.m. Okay, so you don't see the hurricane, right? So let's write down it. So station A, what's the wind speed? It's 2 long ones, so it's 20. Direction, northeast. Cloud cover, 0. Like no clouds, right? 0%. Pressure, 1039.2. You guys can fill in B and C and do that now. So 4, using the readings above, do you think a hurricane is nearby, and explain? So based on what we just did up here, do you think a hurricane is anywhere near these 3 stations? Put that information in there. Next. Again, you can always pause my videos to type your answers in. Now we're going to run the gizmo again. We're going to run it until the weather station data actually shows you that a hurricane is nearby and will make landfall soon. Again, let's pay attention to the cloud coverage, the wind speed, and the air pressure. We've talked about this before. Wind speed should increase, cloud coverage should increase, and air pressure should drop. We're going to do that until we think a hurricane is nearby, and then we're going to hit pause. So take a look at these 3 things and see what happens. See if there's hardly anything around now. Things are picking back up again. things kind of stabilized a little bit. Okay. You see stuff at Station B is starting to pick back up. It's hit 50 knots now. Pressure's on its way to going below 1,000. And let's pause that right there. Okay. What weather station data indicated a hurricane would soon make landfall? Of the three where I paused it, which one is most likely to have a hurricane near it? I'm going to turn on Show Hurricane. And was your prediction right? So here for A, you're going to say what station? Is it A, B, or C? Were you right with your prediction of A, B, or C, or above? That's what you're doing here. Let's move on. Last part here. So we're going to turn off Show Hurricane, and we're going to reset at noon of day one. We're going to pause, and from the Tools menu, we're going to drag a pointer to the predicted position of the eye in the hurricane. Draw label the arrow. Label this arrow 1. Okay. We're going to ignore this last part, guys, because it involves you trying to put stuff on the map here. And I'm not going to make you guys draw things on this map. It's kind of annoying. So we won't do that. We'll just move on. So let's do the last question here. As warm, moist air rises, water vapor in the air condenses and releases a great deal of heat energy. This energy powers a hurricane. How does this information explain what happens to hurricanes after they make landfall? So this part right here, so you can, again, you don't have to do this last part here, question 7. You can ignore all that stuff, okay? And let's just do 8. So reading this, knowing that hurricanes tend to die away as they make land, how does this statement help support that idea that hurricanes die away as they go to land? Okay. Once you guys finish this, you can save it on your computer and upload it into the folder where you got this document from, and that is it for this lab.